All right, we got to do the same thing now for tangent. You get all the big 3 in there. And so tangent, this is where we cut it. So again, you can see it would not be 1-to-1 if we keep going all the way across. It's going to hit twice. So from negative pi over 2 to pi over 2, just like sine. So tangent and sine, exact same regions, exact same stuff, except the range for tangent is from negative infinity to infinity, because it goes off to positive infinity and then down to negative infinity. It also has an issue here that I wrote, but we need to change. This, it's actually a good mistake, so now we have to focus on it. It's supposed to be parentheses, because from negative pi over 2 to pi over 2. That's what happens when you copy and paste. Up here too, look at that. There's parentheses. Everything gets parentheses. No brackets. Parentheses on everything, for tangent, that is. So tangent goes off to positive infinity, down to negative infinity, from negative pi over 2 to pi over 2. All right, and so it's 1-to-1 here, so if it's 1-to-1, then we get this. And so we did now, since we've fixed our domain for this function, we can now get a range for that function. So the inverse, dude, there's just mistakes everywhere. And if this wasn't a quick summer class, I would be rewriting these, but we don't have time. It's actually, we are in the fall now, and I've got to get through all of this. So x equals inverse tangent y, and rewriting is good. And so this is our inverse, and it goes from negative infinity to infinity. Negative pi over 2 to pi over 2 is our range. So same basic idea as before. We have to make sure that if we're going to be plugging into tangent, we need to make sure our domain stays here to apply our inverse rules. And this one's for all real numbers. So no matter what, with an inverse tangent, you plug in an x, it spits out an x. Pretty nice, right? So if you plug in a half, it spits out a half. If you plug in 4,000, it spits out 4,000, like this. Second tangent. Oops, wrong one first. Let's get rid of the sign, so we're just doing tangent. Second tangent, and then 4,000. So anything you want to plug in there. And we hit enter, it says 4,000. So it works perfectly well. All right. So basically, if you want to apply this rule, you've got to be between negative pi over 2 and pi over 2 for your inputs. And if you want to apply this rule, just plug a number that's real in it. All right, so tangent inverse of 2. So that one's good to go. See, so for tangents, we can plug anything we want into the inverse. So you just pull up your calculator, you go inverse tangent of 2, you hit enter, and it spits out the angle. And this is in degrees, so it's 63.4 degrees. You can do radians if you want as well. You just go and change your calculator settings to radians. Hit second quit, hit enter, and there you go, 1.107. So 1.107 degrees radians. Now, same with a decimal. Remember, this is all real numbers. So if you have a decimal, you just plug that in as well. Second inverse, and then we put in 0.2. Hit enter, and it spits out the radians. So 0.197. And then we change the mode to degrees. Hit enter, and now we have the degrees, 11.31 degrees. And so now when we apply this rule, we're not going to plug it in anymore. Tangent 2 we know is this, and if you plug this into tangent, it's just going to spit it out. So as long as this is what we're dealing with, which is here, you can see this is just 2. And you can use your calculator to verify that as well. So the same thing here, what would this one be? Perfect, 1. And what would this one be? Perfect, 45 degrees. See, because it fits within there. What's this one be? 225. Wrong. It's not 225. So we have to be within this domain for this to work. So we have to actually find out what tangent of 225 is. So we go up to our unit circle, and we go to 225 because we want an exact value here. 225 would be negative rad 2 over negative rad 2, right? So tangent of 225, if we're going to do this the old school way, we should already know how to do this by now, but if we divide these, you can see we get 1. So that is 1. Now we can find the inverse. So you can only apply these rules, again, if you're inputting between negative pi over 2 and pi over 2. And that, again, would be negative 90 degrees and 90 degrees. And we're outside that domain. So, or range, depending depending on what we're talking about. So we have inverse tangent of 1 now, so now we can go back up. And inverse tangent of 1, again, this is not the sine and the cosine, it's together, right? Tangent is sine over cosine. So rad 2 over rad 2 would be pi over 4. So what you can kind of do that's even quicker is if you see 225, okay, well, these are the positives, right, for tangent. Remember, all students take calculus. So this is going to be positive tangent, negative tangent, negative tangent. So if it came out to be 3 pi over 4, right, you know the answer is 7 pi over 4 if you were to plug it through there. Like this one came out to be 225, so we know the answer is 45 degrees. I should probably put 45 there. So that's what I'm talking about. They just transfer right on over. You can use the line itself to find it. So if they had given us this exact same thing, here, let's just write it over here. Let's do some more. It's always good to have extra. If we do sine, exact same way, tangent, sorry. Doesn't really matter, they're both the same. Tangent, exact same. So all we're going to do is pick a different angle in here. Tangent inverse of tangent. And we're going to plug in, say, 5 pi over 6. So it's outside the range, so we can't apply this rule. So, but at 5 pi over 6, we're going to get a negative value. So if you just transfer that line right over here, you can see it's the same two numbers. This is 1/2 over rad 3 over 2. This is 1/2 over rad 3 over 2. That would come out to be negative. That would come out to be negative. So what it's going to give us is 11 pi over 6. We're just making sure we stay within our window. So if it goes outside the window, just shove it right back in. And if it goes outside the window, you shove it right back in. You can just transfer right across the lines here. So if you were to get 2 pi over 3 as the angle you're plugging in to this situation, you would just shove it right back over to 5 pi over 3, the same values that it would give you. And you can check these. So if you're like, oh, this just seems too complicated, relax. Use your calculator to verify everything. So if you input it in, it's not going to give you the exact value, but what you can do is use your calculator to check it. Now we do need to make sure that we are in radians here. So mode, hit enter, so I can quit. So inverse tangent of tangent 5 pi over 6, you hit enter, and it gives you this, right? And so we now just plug in 11 pi over 6, right? And it gives us this. And you're like, well, wait, that's not the same. This is a negative. This is a positive. So if we want to find out what that difference is, all you have to do now is subtract 2 second pi. And I'm fine with the coterminal angle. These are the same thing, see? So if we think about 11 pi over 6, you subtract it from 2 pi, you're going to get the same thing. And there you have it. All right, and if you held on to the end, we've got some fixing to do. I need to slow down when we're doing this stuff, but it's negative 90 degrees less than x, less than 90 degrees. These should all be less than. They're not going to actually hit because they're undefined at that value. Same thing here, you can't actually get to negative infinity. Remember, no brackets on anything, so that means no equal signs on anything as well. Okay, now it should be fixed. Can I find anything else? Looks good. We got parentheses equals everything. I guess it's a nice result that we have to go back and fix it. So it's always good to have problems that we fix. Very good.